Hey guys, this is week 5. We're starting off with a review of some fourth grade standards that are going to help us as we simplify our equivalent ratios. So back in fourth grade, you were taught how to reduce fractions to simplest terms. So we're going to kind of review that skill, and it's going to help us as we try to come up with this, break down our ratios to simplest forms. So let's take 4/8. Both of those numbers have to be divisible by something for us to simplify this or reduce this into simpler terms. So we can make a chart here to talk about what factors are inside those numbers. Now we know both of them have a factor of 1. So we know 1 and 4, and we know that 2 times 2 is 4. So these are all of 4's factors, right? What numbers could we multiply to create 8? Have a product of 8. Well, 1 times 8, 2 times 4. Anything else? No, can't be 3. So those are all the factors for 8. We are going to look for our greatest common factor. What is the largest number both numbers have? Do both numbers have 8? No. Do both numbers have 4 as a factor? Yes. So this GCF is going to help us simplify 4/8 into its using the smallest digits. So we can take our greatest common factor, divide the numerator by 4 and the denominator by 4. Now, just a cool little side note, what does 4/4 equal? That's me drawing the number 1. We're just dividing this fraction by a version of 1, which means we're not changing it. We're just reducing it into different digits that mean the same quantity. So 4, get my purple back, 4 divided by 4 equals 1, and 8 divided by 4 equals 2. So we can see that 4/8 is equivalent to 1/2. If I'm going too fast, hit pause on your computer and hit play when you're ready to move on. So up here, you could write 4/8 divided by 4/4 equals 1/2. Okay? All right, let's look at 12/36. We need to find the greatest common factor for 12 and 36. So let's start with 1 times 12. Does 2 work? Oop, it's not 2. Get the little eraser here. It was a 6. 2 times what number gives us 6? 12. 2 times 6. So see, I'm listing the pairs. This is a pair and that's a pair. Can we use 3 times anything to get to 4? Yes, 3 times 4 is 12. So here are the factors of 12. We're going to do the same thing for 13. 36. 1 times 36. 2 times 18. 3 times 12. Does 4 go into 36? It does. 4 and 9 and 6 times 6. Write these out better. So I've listed all the numbers that fit into 36 neatly. In the top row is the 12's multiples. Let's find our greatest common factor. Let's start with the largest factor. Does 12 have 36? No. So 36 does not work. Let me clear these off, because we wrote them in a better row over here. We're looking for the largest digit that both numbers can be divided by. Is 18 on the top row with the 12s? Is not. But I can see that 12 is a factor of 36 and 12 is a factor of 12, which means I can take 12/36 divided by that greatest common factor, 12/12, and this will help me reduce my fraction into simplest forms. 12 divided by 12 equals 1. 36 divided by 12 equals 3. So we could say that 12/36 is equivalent to 1/3. I'm going to delete all this, so please hit pause while you kind of write down your thinking here. This will look like your test on Friday, so it's important to write down the things that are going to help you remember how to simplify another set of numbers. Don't just write down everything I say. Write it down, write everything I say, but also think about yourself using these notes to help you solve another one. Like you may want to write, why did we cross those numbers out? They didn't have a matching pair. All right, so we know that 4/8 is equivalent to 1/2. 12/36 is equivalent to 1/3. And now we have 11/44. Well, if we find all their factors, we know 1 times 11 is all we have for 11. And we can do 1 times 44. We can do 2, what that be, times 22, and then 4 times 11. These are all the factors. Let me make that messy again. Let me clean it up. So 1 times 44, 2 times 22, and 4 times 11. These are all the factors. Remember, we need the greatest common factor. We don't have 44 up top. We don't have 22 up top, but both numbers have an 11. So if we take 11/44 and divide it by a version of the number 1, we're going to use 11/11. Well, 11 divided by 11 equals 1. 44 divided by 11 equals 4. So 11/44 can be simplified to 1/4. Take a minute, organize your notes, make sure you understand the process that we're going through so you can replicate this on Friday's quiz. All right, so we were able to see that 4/8 is 1/2, 12/36 is 1/3, and we showed that 11/44 is 1/4. Now we're going to look at 15/40. So we need to come up with all their factors. 1 times 15. Well, I can't use 2. That doesn't need to be up there. But I know that 3 times 5. And I can't use 4. So the only ones that I'm going to list for 15 are 1, 3, 5, and 15. And remember, we're talking about factors. So 1 times 15 is 15. 3 times 5 is 15. And we have to list the same factors for 40. And I know that 1 times 40 is 40. 2 times 20 is 40. Can 3 go into 40? No. 4 can. 4 times 10. 5 times 8. And then the only numbers in between here are 6 and 7. I know those don't work. So we have all the factors of 40. We're going to look for our greatest common factor. 40 is not on top. 20 is not on top. 15 is not on bottom, right? 10 isn't on top. 8 isn't on top. Our first common factor is 5. The 5 is on top and the 5 is on bottom. It's a factor of both of our numbers. It's the largest factor of both of our numbers. So we're going to use 5/5 to help us reduce our fraction. 15 divided by 5 equals 3. 40 divided by 5 equals 8. And don't forget this cool little trick of knowing that 5/5 is really the whole number 1. And when you divide a number by 1, you really get its same thing. We're just getting another version, a simpler version with smaller digits. So 15/40 is 3/8. Make your notes so that you can make sense of what we did. We crossed all these numbers out because they weren't a common factor. There wasn't 40 on top also, so we couldn't use it. 15 was only on top. It wasn't on bottom. Couldn't use it. 20 was only on bottom. It wasn't a multiple of 15. 10 didn't have a matching multiple. 8 didn't have a matching multiple. That's how we picked 5/5. Okay, so now we're looking at 24/60. First, let's list out all our factors, starting with 1 times 24. Then I like to go to the next number. 2 times 12. 3 times 8. 4 times 6. And the only number in between there is 5. And I know some know I'm done because that doesn't work. Multiples of 60. 1 times 60. 2 times 30. 3 times 20, 4 times 15, 5 times 12, 6 times 10, and those are the only ones. So I kind of squished them in there. Let's start with the largest factor and see if it has a matching set. Is there a 60 on top? No. Is there a 30 on top? No. 24 is big, but is it on bottom? No. Is there a 20 on top and on bottom? No. Is there a 15 on top and on bottom? No. Is there a 12 on top? Yes. So here I have common factors. It's the greatest, the biggest factor they both have in common. So we will take our fraction, 24/60, and divide it by the greatest common factor, which is 12/12. 24 divided by 12 is 2. 60 divided by 12 is 5. So our fraction can be reduced to 2/5. All right, I'm going to assign this on Khan Academy about reducing in simplest forms, but this strategy of listing all your multiples is very helpful to make sure you're in simplest form. Great job, mathematicians. Let me see how I get on to the next. Where's the mouse? There it is. All right, so here we are now. Let me get out of this. I need the pen. There's a pen. A 6-pack of gum costs $6.78. What is the price in dollars of 1 pack of gum? All right, well, your handy dandy tape diagram is the key for this. So I just want to model out 6 of something. 5 walls create 6 units. And so I know all 6 of these packs of gum have a total cost of $6.78. So how would I determine the cost of 1 unit? Why don't you hit pause on the computer and see if you can figure it out and hit play when you're ready to show me and check your work. So by using this tape, we can see that we can take $6.78, divide it into 6 groups, split it equally. 6 goes into 6 one time. I think I'm going to change my ink. 6 goes into 6 one time. 1 times 6 is 6. 0. Hey guys, I don't like working when I don't have a lot of scratch paper, so I'm going to clear this off a little bit. Get my eraser. But I want to leave that tape diagram. I just want to not make this so messy. And I write this with my finger, so if it looks a little off, that's why. So we're going to take our whole, which is $6.78, and we need to divide it into 6 equal groups. 6 divided by 6 is 1. We distribute out that 6. There's nothing left. We bring down our 7. It's real important that we remember that our 7's in the 10th place. So we got to put this decimal here. 6 goes into 7 one time. 7 minus 6 is 1. Bring down the 8. 18 divided by 6 is 3. That uses all 18. There's not a remainder. So each pack of gum is $1.13. I wonder how a mathematician could check their work. I saw a lot of errors on last Friday's test. It was a really easy question, but the errors were because I could tell the mathematicians didn't check their work. And if you don't check your division problems with multiplication, then you're going to make a typical 6th grade mistake, but it probably would have been preventable. So let's see if 6 sets of $1.13 will give us the total cost. 6 times 3 is 18. Why don't you hit pause and work this yourself and then check your work. 6 times 1 is 6 plus 1 is 7. And 6 times 1 is 6. 2 digits behind the decimal. Fantastic. By checking my work, I don't throw a point away. I get everything that I know how to do, and I do my best work, and I turn it in. A lot of mistakes on last Friday's test. It's just silly, careless mistakes. And we don't want to have careless mistakes. We want our mistakes to be because we don't understand the math, because a Miss Masur can help you or Miss Cosby can help you with the math. So we don't want careless mistakes. All mathematicians should check every division problem with multiplication. I'm going to clear the screen. So remember, you control the speed of this lesson using the play and rewind button. All right, so here we just have a couple of decimal problems in a row. And in 6th grade, they're going to be testing your understanding of place values. So my suggestion is for every decimal addition and subtraction is to put them on a place value chart. 6 and 5 in the 10th place, 4 in the 100th place. That will help you line this digit up. You're subtracting like place values. That helps you see that there's something missing. There's a void. And so you're going to have to put a 0 there. I promise you will see a 3-digit problem minus a 4-digit problem on the leave test. I promise you. So it's really important you start to understand the importance of lining these decimals up so that you know to put a 0 in that last place if needed. So why don't you hit pause on the computer while you subtract, then hit play to check your work. All right, so I don't have any in thousands place, so I have to go to the hundreds place, and we're going to use one of the larger digits to make 10 of the smaller units. 10 minus 3 is 7. Can I do 3 minus 9? I can't. So I'm going to go to the tenths place, take one larger tenth, and it makes an additional 10 smaller hundreds. Instead of 3 hundreds, I now have 13 hundreds. 9 plus 4 more gives me 13. 4 minus 4 is 0. Don't forget the decimal always is between the tenths and the ones place. 6 minus 1 is 5. This is one of those on Friday's test last week that there were a ton of careless errors also. You can check easily this problem with the inverse operation. All subtraction problems should be checked with addition. Let's put those two parts back together. If I take the two smaller parts and add them back together, made a mistake. You can find that right here. I should have back the number I started with. I know it takes a little bit of time to do this, but so many points were given away on Friday's test because I could tell students didn't check their work. So many careless mistakes were made. In fact, the number one mistake was right here. My sweet students just put a 3 down here as the answer instead of regrouping. So if you would check your work, you would find those little mistakes. So let's add our work together. That's 10, 9, 10, 11, 12, 13, 14, 5, bring down the decimal, 6. This is the same as a number I started with. And by spending just about 15 seconds checking my work, I'm going to have a better grade. This type problem most definitely will be on your LEAP test. And by using these strategies, you won't make a careless mistake. All right, same for this one. It's addition of decimals. They're going to give you 2 3-digit numbers and add them together. What you've got to put them in a place value chart so that you can see that this 3 is in the tens place. This 4 is in the ones place. Here's the decimal. That's the tenths place. By making that decimal there in the place value chart, now you see that the 3 can't go over here. A lot of y'all would have put that 3 right here. It doesn't go there. It's in the ones place. The 3, the 6, and the 5. It is super important that you start to realize that when we add decimals, you have to line that decimal up because we're adding like place values. We have to add thousands to the thousands. We have 0 hundreds and 5 hundreds, which gives us 500s. We have to add tenths to tenths. 5 tenths and 6 tenths is 11 tenths. The decimal always separates our decimal numbers and our whole numbers. Now we're adding the ones place, 4, 5, 6, 7, 8. And then we have 3 tenths and 0 tenths, which is 3 tenths. Right, so this is the correct answer. I want to show you what I promise you I will see probably. Let's see if I clean this off real quick. I'm about to show you the common mistake that I know I will get on Friday's test. You ready? I'm telling you, this is a typical 6th grade mistake that I want you to try to be careful not to make because this is wrong. 34 and 5 tenths plus 3 and 65 hundredths does not equal 710, nor does it equal 7 and 1 tenth. That doesn't make any sense. Our estimate is we have about 34 and we're adding about 3, which should give us about 37. By lining those digits up, we have 38 and 15 hundredths. Please don't make a silly 6th grade mistake on this one. This is an easy LEAP point to get. And it's actually a 5th grade skill. All right, mathematicians, hit pause if you need more time. I'm going to clear the screen. All right, so we're going to do 2 division problems this week. Both have a 1-digit divisor. 4,739 divided into 7 equal groups. Please take the time to start your skip count listing your multiples. 7 plus 7 is 14. 14 plus 7 is 21. 21 plus 7 is 28. You can just skip count all the way down. I actually have a 7 song that I've been singing since I was a little girl. 7, 14, 21, 28, 35, 42, 49, 56, 63, and then 70. That's how I skip count by sevens. I know it's silly, but still, as a grown up, I am skip counting by sevens using a song because it works. You can do the same thing. All right, so now we have a list of our multiples here, and it's going to help us solve this. Can we take 4 and split into 7 groups? We cannot. Some of y'all find success by putting a 0 there. But we can take 47 and split it into 7 groups. Let's see, let's come down our list over here. I see 42. Can't use 49, it's too much. So how many sets of 7 is 42? 1, 2, 3, 4, 5, 6. 6 groups of 7 is 42. And that is what we subtract for first. Okay? Now, let's work with the 3. Now we have 53. 56 over here is too much, but 49 would work. That's 7 groups of 7. 7 groups of 7 would be 49. Let's subtract it out, which leaves us 4. Bring down a 9. Oh, there's 7 times 7 again. We have no remainder for this one. Mathematicians, what do all good mathematicians do after they have solved their problem? All division problems need to be solved with multiplication. Please, please, please take a few minutes to take that quotient and multiply it by that divisor. This is how you find careless mistakes. This is how you change a 5 out of a 10 on a test to an 8 out of a 10. That's going from an F to a high C. Okay? 7 times 7 is 49. 7 times 7 is 49. 4, 50, 51, 52, 53. 6 times 7 is 42, 43, 44, 45, 46, 47. Is that what I started with? Yes. That means this quotient is probably correct. All right. This step is crazy important. In fact, on the LEAP test, they're even going to probably say, what is the quotient for 47 and 4,739 divided by 7? List the quotient, show or explain your work. So how are we going to show or explain our work? You have to type it in. It might even say, how would you check your work with multiplication? You would say, I would check my work with multiplication, and you could type in this equation, right? Because that's what we did. All right, mathematicians, I'm going to clear it. So hit pause if you need more time. See you in a few minutes. All right, we have another division problem, and this one's got a tricky little spot in it that I noticed on this week that y'all need a little bit more support and practice with. So first step, let's skip count by 4. 4 plus 4 is 8. 8 plus 4 is 12. 12 plus 4 is 16. 16 plus 4 is 20. And you just keep skip counting by 4s. If you get stuck, just add on 4. All right. How many times can 4 go into 1? It cannot. But 4 can go into 12 3 times, right? I don't like this messy thing, so I'm going to erase this little thing right here. And the reason it's not over the top of the 2 is because we're working with 12. So 3 times 4 is 12, and there's nothing left. So when we bring down the 3, 3 isn't big enough to even be one multiple of 4. So this is where y'all's mistakes were last week. A lot of you were like, well, I can't do anything with 3, so I'm going to go ahead and bring down the 2. No. The minute you bring down that 3, you have to work with the 3. If you bring it down, it needs something on top. So a 0 goes there. 4 times 0 is 0. We still have 3. Now you can bring down the 2. 4 goes into 32 8 times. Because there's a big difference between 38, which is what y'all were doing last week when you didn't do anything with these zeros, and 308. So it's a very important skill to understand. Sometimes you'll have a 0 in the quotient. Mathematicians, what do we do after we divide? We check our work. We don't want to give an easy point away. 8 times 4 is 32. 4 times 0 is 0 plus 3. 4 times 3 is 12. This helps me see that my answer is indeed correct, and I can move forward. Okay, hit pause on this computer, and guys, make sure you make some notes about what is a good strategy. If all you do is write down this 38 because you're writing down everything I said, well, how is that going to help you on Friday? You need to write down the 0 is very important. 38 is different than 308. so that you're careful that 3 you have to put something there. All right. We have multi-digit multiplication. You started this in 4th grade and worked with it again last year, and we're perfecting it this year. Let's just start with the 2. 2 times 5 is 10. Carry that 1. 2 times 4 is 8, plus 1 more is 9. Hey, by the way, hit pause, work this out yourself, then watch me do it while you check your work. I don't want you working it with me. I want you working it and then watching me to check your work. All right, so we did 2 times 5 is 10, 4 times 2 is 8, plus 1 is 9, and 2 times 3 is 6, right? Finish with the 2, placeholder 0. In fact, I'm going to cross off that 1 because I'm done with it also. So now this next one is going to be dealing with the 3. 3 times 5 is 15. Carry a new 1. 3 times 4 is 12, plus 1 is 13. Carry a 1. 3 times 3 is 9, plus 1 is 10. Add your 2 partial products. And there you go. Always check your work. Since I'm working quickly, I'm going to rework it a second time because it's worth my time. Even grown-ups make math mistakes, especially when you're trying to record a video, right? 15, 1, 13, 1, 10. Talking to myself. Yep, got it twice. All right, hit pause if you need a few more minutes. All right, so here you have a word problem. And I want you to hit pause and kind of look at it after I explain it. It gives you a chart, and it's got all these different number of hours worked, 4 hours, 5 hours. We have the variable H here. That's a variable. It's just standing for a number. And we have 10 and we have 12. And then it says amount paid in money. So every time I think it's babysat. Every time she worked 4 hours, she made $32. When she worked 5 hours, she made $40. We don't know how many hours she worked to make $56. 10 hours, $80, $12, $96. But we do know it's at the same rate. And that helps us see how we can look for the constant. What is being done to these top numbers? What is it being multiplied? Let me get my pen back. So think, some of you might even want, if you could write it even like this, 432. It might help you see it. These tables can be written left to right. They can be written up and down. How did they get from 4 to 32? What was it multiplied by? 4 times what number? Well, 4 times 8. Does that work for 5? 5 times what number? Well, 5 times 8. You could also even take this. Okay. She worked 4 equal units and made $32. 32 divided into 4 equal groups equals $8 for each of those hours. And in 5 groups of 8, 10 times 8, did that work? That's right. That's the constant. 12 times 8. Yep. So how does that help us solve what is H? Well, H times 8 has to equal 56. And so we could ask ourselves 56 divided into 8 would be how much? 56 divided, it's 7. That is how you could see that 7 hours were worked because 7 times that constant of 8 equals 56. All righty. Hit pause if you need a few more minutes. All right, here we have a ratio. It even says the ratio is, and then you see this clue here, 5 to 3. I'm going to go ahead and write it. And it says it's ladybugs to crickets. It says if there are 64 total. Guys, when you hear that, go ahead and write the word total. See if you can solve this problem without me from here on. All right, it says if later on in life there are 64 of them, well, how many ladybugs are there and how many crickets are there? If you're given the total and you're given the ratio, you need to come up here. Oh no, can I go back? I cannot. All right, I had to rewrite it. Okay, if you're given the total down here, like a big total, You have to come up here and find the total for this simplified ratio. If you just had 5 ladybugs and you just had 3 crickets, then you would have a total of 8, right? So 8 times what constant, what mystery number, would give us 64? 8 times what number equals 64? And when you have a multiplication sentence with a missing factor, you can use the inverse operation and say 64 divided by 8 equals what? That's right. Oh no. All right, I drew it again. If you know that this was multiplied by 8, then your crickets have to be multiplied by 8, and your ladybugs will be multiplied by 8. So you can see there's 40 ladybugs, 24 crickets, because there were 64 total. Now, here's the key. Don't just type into the test 40, 24. It didn't ask you for that. It gave you 2 specific questions. And on the LEAP test, if they ask you 2 specific questions, those questions have to be specifically answered. If you type this in on Friday, Ms. Cosby and I will know you did all the work, but we will have to give you 0 points. How many ladybugs are there? There are 40 ladybugs, period. How many crickets are there? There are 24 crickets. This is what's asked. How many ladybugs are there? How many crickets? There are 40 ladybugs. There are 24 crickets. Writing that ratio is going to give you 0 points because it did not ask for a ratio. There are questions that ask for a ratio, but this one did not ask for a ratio. All right. This is another similar question. You'll work it the same way, but it's asking a different question. Let's read it together. The ratio of chocolate cupcakes to vanilla cupcakes is 2 to 5. If there are a total of 21 cupcakes, how many more, get my pen, how many more vanilla cupcakes are there? It's not asking you how many vanilla or how many chocolate. It says how many more vanilla. So since we see it's a ratio, let's write a table out. We've got chocolate and we got vanilla, and their ratio is 2 to 5. I do see that they're talking about a total, so I'm going to make a total row. And it says later on there'll be 21 total. Well, right now there's 7 total. What is the constant? How did they go from 7 to 21? 7 times 3. So the constant's 3. That means vanilla has to be multiplied by 3. And chocolate, which is a 2, has to be multiplied by 3. 6 chocolate cupcakes, 15 vanilla cupcakes. You cannot put that as the answer. It did not say to you, how many chocolate cupcakes are there? It did not say, how many vanilla cupcakes are there? It said, how many more vanilla? So you take the vanilla, you subtract the chocolate, which leaves you 9 more vanilla. See the difference? It is the same work, the same math. We get a different color. The same math is happening as the question we just did with ladybugs and crickets. You just have to pay attention to what information do they want and make sure you answer the question specifically. I think that might be the last one. All right, guys. Thank you for watching the video with me. I hope you have a lovely week, and I will see you at school.